In this video, we're going to be talking about polynomials and how to add and subtract polynomials and classify polynomials. So first, we have some vocabulary to go over. The first term that we're going to look at is something called a monomial. So you might have seen this prefix mono before, meaning one. And basically what a monomial is an expression that is a number, a variable, or a product of a number and variables. So it's a one-term polynomial. So that's where the term mono is coming from, is it being a one-term polynomial. So an example would be something like 4, that's just a number, or you could have something like x, that's a variable, and then a product of numbers, of a number and variables. So like 3x to the 6th, that would be another monomial example. So a polynomial is just a sum of one or more monomials. So you just take all the monomials and you can just add them together to get more terms. And basically a polynomial is just multiple terms, all of the same form as a monomial. So an example would be something like 3 plus 7x plus 5x to the 4th. This would be a polynomial with 3 terms. So we have 1 term, 2 terms, 3 terms being added together. Now, when we talk about the degree of the polynomial is indicated by the exponent, and it's the highest sum of exponents in a single term. So you have a term, or if you have your polynomial, you just look at all of your terms and you try and find which one has the highest exponent, and that's going to be the degree of your polynomial. Now, when we're talking, the reason why we care about degree is because we want generally to write our polynomials in something called standard form. And standard form is when each term is decreasing by its exponent. So the degree of each term goes down from left to right. So let's take a look at how to write some terms, some examples in standard form. Actually, we're going to classify polynomials first. Sorry. So when we say classify, basically classify just means name the polynomial. So we're going to name it based on its degree. So the degree is indicated by the exponent of your variable, actually. So in this case, we have negative 15 here. It doesn't look like there's any variable. And so we actually have a degree of 0 here. And since there's no variable, this number doesn't change, and we call that constant. Now, the reason why it's actually a degree of 0 is we could think of this as 15 times x to the 0 power. And because x to the 0 power is just 1, so 15 times 1, or negative 15 times 1 is still just negative 15. And with it having a power of 0, that's why its degree is 0. In this, we have a 3x to the first, and then again we have our 5x to the 0. So the highest exponent would be a 1 here. And if you recall, this looks very similar to what we have when we talk about slope-intercept form, y equals mx plus b, and the graph of those are lines. So this is called a linear polynomial. So it's linear. In this one, this is again x to the 0, so its power is 0, and then this power is 2 here. So the 2 is bigger, so it's a second degree polynomial, and we call that a quadratic. So quadratic is for a second degree polynomial. In this case, we have a 3 here. Whoop, that was weird. We have a 3 here. We have an x to the first, and this would be x to the 0. So 3 is going to be our highest exponent. And with a degree of 3, that means we have a cubic polynomial. These four are the 4 that you need to memorize. Degree of 0, degree of 1, degree of 2, degree of 3. So 0 degree is constant, first degree is linear, second is quadratic, third degree is cubic. Anything above that, we're just going to name based on the number. So in this example, right, we have a 7, a 5, a 3, a 2, and then a 0. So with the 7 being the highest, this is the 7th degree polynomial, and we're going to call it exactly that. We'll just call it 7th degree. So 7th degree. So these ones here are the ones you need to memorize. 0 through 3 degrees. Now, how would we classify these same polynomials based on the number of terms? So if we're classifying based on the number of terms, we want to count how many terms there are and then give them their name according to that. So this is just a single term, one term. And we saw that in the definitions that anything that's just a single term we call a monomial. So it's a monomial. Mono meaning one. This has two terms. So you can, a term is always separated by an addition or subtraction sign. So we have the 3x and then we have the -5. So there are two terms there. And a two-term polynomial is called a binomial. Bi like bicycle, meaning two, right? Binomial. So again, this has two terms, so it is again a binomial. In this situation here, we have 1, 2, 3 terms. And a three-term polynomial we call a trinomial. So again, these are the only three that really have a special name. Monomial for one term, binomial for two terms, trinomial for three terms. Anything after that, we just call it generally a polynomial. Technically, all of these are polynomials as well, but these three have special names. So in this case, we have 1, 2, 3, 4, 5 different pieces separated by an addition or subtraction sign. So that means it has 5 terms. And we would just call it a polynomial, which technically all of these are as well. But this is a 5-term polynomial. Okay, so now let's talk about classifying with standard form. So putting things in standard form. So when we're trying to put an expression in standard form, it needs to go from the highest degree to the lowest degree. So you want to pick the highest exponent to the lowest exponent. So in this case, this term has the highest exponent, so it needs to be listed first. So it's going to be 17x squared. This will be to the first, so plus 8x. And then this has a degree of 0, so it's going to be minus 25. Now, when you're doing these, you need to be careful that you're paying attention to the signs in front of your terms, because those dictate the sign of your actual term itself. So in this case, we have just two terms, right? So this is a binomial. We have this cubic and then this linear term here. So since this is a third degree, that's going to be first. And we see that it has the negative here. So it's going to be negative 2x to the third and then plus 35x. Even though there's not a sign in front here, if it's positive, it would be plus 35x. And then the last one, there's 1, 2, 3, 4, 5 terms here. This fourth degree is the highest, so we're going to put x to the fourth. No third degree, but we have a second degree here, so it's going to be minus 3x squared. A first degree, we have one there, so plus 25x. And then we have two constants. We have this and this. So which one would come first? Actually, we don't want to keep them separate. We want to put them together. So anytime you have something that can be put together, we call those like terms. And like terms happen when they have the exact same variable makeup, right? So 25x, if there was another, like let's say 15x, then we could subtract these to make them 10x. We could combine them because they have the exact same variable composition. 25x and 15x squared are not like terms because they don't have the same exponent. So because those have different exponents, we would not be able to combine those. And that's also why we have to leave these separate. So 15 minus 3, that's going to be positive 12. And so that would be what we're left with as far as our constants. So this would be the standard form expression for that polynomial there. So how do we add polynomials? So in order to add polynomials, we just basically add our like terms. So I generally try and look for the highest degree term in our polynomial because we want it to be written in standard form, and that's going to go first. So the highest degree term is second. So we have this 4x squared, and that's going to be added to 2x squared. So when you're combining like terms, all you really need to do is add the number in front. That number in front is called the coefficient. So 4x squared plus 2x squared, that's going to be 6x squared. So the exponents don't change because in order to add them, they have to have the same exponent. And all we do is we change the number that's in front of them. So here we have a 6x, and then we're adding a negative 9x. So 6 plus negative 9, that's going to be negative 3x. And then our constant terms, we have a positive 7 and a positive 1. So 7 plus 1 is 8. So then we have 6x squared minus 3x plus 8. So this has three terms, 1, 2, 3. So that's going to be a trinomial, and its degree is 2. So now we're doing the classifying part. So this would be a quadratic, and then three terms means it's a trinomial. So quadratic trinomial. All right, so let's take a look at another example. So again, we're adding. So what's our highest degree term in this? We have something to the fourth. That's our highest degree. So we have 8p to the fourth plus 6p to the fourth. So 8 plus 6, that is 14. So we're going to get 14p to the fourth. So we're done with those. This doesn't have any cubic terms, but I do see that I have a cubic term over here. So it's a positive p to the third. So it's plus p to the third. We can be done with that one. So moving down, we're looking at second degree terms. So we have a 3p squared plus a negative 2p. So 3 plus negative 2, that's 1. So we're going to get 1p. We don't have to write the 1. We can just write p. And then the degree stays the same. So those are done. And then we have this linear term. There's nothing else to add it to, so it will just stay the same as 15p. And that would be our polynomial here. Now there's 4 terms, so we're just going to call it a polynomial. And the degree is 4. So this is a 4th degree. And then polynomial because it has 4 terms. So 4th degree polynomial. Now, how is this different when we are subtracting? So if I wanted to subtract, so we're subtracting here, there's a couple ways that you can think about this. You can think about it as taking your terms and just subtracting like terms. Or sometimes people like to change this subtraction to an addition by distributing the negative through. Essentially, what that does is it changes all of your signs. So you can take this negative and distribute it through to everything in the polynomial after the subtraction sign, and that would change this to an addition by the opposite signs, right? And then you can just combine your like terms that way. So basically you have to take this negative and distribute it through. So that's one approach, or you could just think to yourself, what is 2x to the third minus 1x to the third, and do the subtraction that way. I prefer the distributing, so I'm going to do it that way. So add this through. So I'm going to change all my signs and then go from there. So what is 2x to the third plus a negative 1x to the third? So 2 plus negative 1, that is just 1. So we can just write that as x to the third. 5x squared plus 8x squared. So 5 plus 8, that's going to be 13. So plus 13x squared. Negative 3x plus, there are no other linear terms, so it's just going to stay negative 3x. So we have taken care of those. And now we have this plus negative 11. So it's just going to be minus 11. This one doesn't ask us to do it, but it's a 3rd degree polynomial, so it's a cubic polynomial.